hello everybody. Thank you, Marta, for this presentation. That was really interesting. And I think that will make a good transition with what I will present now. So I will probably get back to the basics about SBOM. What is it? What is it? Does exist? How you can generate that with Yocto? Just to present myself in few words, so I'm Pierre Gal, working in this embedded ecosystem for now 20 years. I'm working at Yocto, and I'm building a new brand named the Embedded Kit, where we aim to support OEMs to build, create new embedded projects. And we have different set of products to help them to create secured product. So I will be able to present that a little bit after the presentation. We will talk about SBOM, starting by what is it? Just the basics. So try to, yeah. So what do we find in a software bill of materials? And basically, it's a comprehensive inventory that integrates all the software components, all the dependencies used in a system. You can find an SBOM for a specific, just a specific application you are building, defining all the different dependencies that exist to this application. Qt have just released a new framework to generate an SBOM for the project itself and all these dependencies. Yocto offer a mechanism to generate SBOM that integrate all the different software components, software libraries integrated into the system. The main information you will find is information about all of these different components. And the basics is about versioning, what version of your software is included, what exact version of your system is included, all the dependencies you can find between components, where the components come from. We also find a lot of information about licensing, which is a key topic. And then you can find a lot of different type of additional metadata, depending on the tools that is used to generate this software bill of material. Why do we need software bill of material? And I would like to just highlight 3 items, even if I know that it have probably already presented. Marta do a nice discussion about that. There are others presentation about that, but being able to understand what you have exactly included into your image is a key topic when you are building a system like a global custom distribution for your equipment. You will probably have a lot of dependencies, and understand exactly what is integrated does really make sense for ensuring to understand what is really integrated into the project, the product, which is cheap at the end to a final user, a final customer. The second topic is about the license. We talk a lot about cybersecurity and vulnerability management, but there is also a big topic about license management. For some products, it's mandatory to highlight the type of component and the associated license that are used to integrate into the product. It also helps to understand what are the potential limitations or what you have to do to be compliant with this license. So it's the best way to understand the exact list of components and the associated license, and to share that and to make the good decision for your product in regard of the component you are using. The last topic of the benefit of a software bill of material is definitely what have already been highlighted in the presentation just before, which is a tracking of the security vulnerability. So you are not able to identify a software vulnerability if you have not the exact reference of the software you are included in that. I say that it's not fully true. It exists some solutions that are doing vulnerability analysis directly on the binary, directly matching some pattern on the binary, which could work well. But definitely today, the main and the standard approach, the one used by CV check, the one we use in our own CV checking tools, is tracking the vulnerability based on the exact software enumeration. And for that, we need this software bill of material. So let's start by 2 main formats that exist in software bill of material. We were talking a lot about SPDX because it is the one generated into the create SPDX Yocto recipe. But that's also interesting to understand that it exists another format, which is named CycloneDX, which is quite nice. It's a JSON-based format, which is not natively generated by Yocto, but Savoir faire Linux, do a nice meta layer for doing that, freely available on their GitLab. As you can see on the right part of this slide, you will find all the different information about the SBOM itself. And after that, you will have a huge list of all the components, including licensing, name of the component, type of component, and the versioning. You find here a tag named PURL, and I will get back on this unique identifier model in a dedicated slide just after. What is important to remember is that it's a simple format, JSON 1, that includes all the information you need for managing your licensing and your vulnerabilities. What is interesting with CycloneDX is that it exists a format named VEX that also have been explained before by Marta, which is used to integrate the vulnerabilities directly into this format. And what is interesting is that something that is standardized by the CycloneDX organism. And you can have a big file that integrates both the software bill of material and the vulnerability listing. So what you find in this VEX format, you have an example here where you will find the reference to the NVD. So you can find directly the link to the NIST website. You will find information about the scoring or the rating. First information about the analysis, and the most important, the version which is affected by these vulnerabilities, which will help you to understand if this vulnerability is applicable or not to your specific components that you have integrated into your system. Let's continue with the SPDX format. For the SPDX format, even for CycloneDX, but there is two main formats. And what is interesting is today there is a lot of SPDX 2.2 support in a lot of different tools. And till the latest STIED version of Yocto, you are only able to generate SPDX 2.2 within Yocto. The default format for SPDX 2 is more like a tag value format, where you will find more or less the same type of information that we have seen before. So package name, package URL, license text. I simplify this example because you find a lot of different information text inside this SPDX, but SPDX is mainly more conformity oriented because there is no in this SPDX 2.2 format standard way to integrate vulnerability topics. So that's probably a limitation of this format. So you will have, if you manage that, to find a separated way to extract your vulnerability. You can definitely use the VEX file, but it will not be fully integrated and in the same format. So that's why it comes SPDX 3.0 that will bring back a wider usage. You will find that example here where is JSON back first. You can always generate a tag value format if you prefer, but by default it's more a JSON LD format where you have multiple JSON file with reference between together. And what is interesting with this SPDX format is that you have a lot of different what we call scopes or profile that you can generate and enable inside your file. And you have one which is linked to the cybersecurity and that allow you to integrate information about vulnerabilities. So main difference between SPDX 2 and SPDX 3 is really about the flexibility of the model. This new model is definitely more flexible. You have a lot of possibility to integrate additional metadata with this concept of profile. After that, for the license model, it's more or less the same. You already have some concept of extension and the default format is different, but you can always find a converted version of the tag value to a JSON file. As I said, I would like to just focus a little bit more about these software component identifiers. That's something which is a key topic when you start talking about vulnerability management. And in fact, there is really two words for this unique identifier. You can just use name and version number, but does not really make sense today. And in fact, you find two different approaches. The first one is what we call PURL, package URL, as you've seen in the example. It really looks like a web URL where you will find all the different information. So all the spec is available directly on GitHub, and you find this type, namespace, name, version, and additional information about the package. So more or less, you find all the most important information you need to uniquely identify the component. This is the standard way that, for example, the OSV database used to identify the applicability of a vulnerability. So if you work with the OSV database, you will mainly work with a PUL. On the other side, you have the CPE, which is in fact an official format coming from the NIST and the NVIDIA database itself. So this format have been defined by the NIST organization. Everything is described in a specific documentation available on the NIST website. And the NIST keep an official list of all CPE available. So that means you have a dictionary somewhere in the NIST database, which is available through a publicly available data API that lists all the different components. The format, you will find more or less the same type of information about the version of the model, the product, the vendor, the product, and the version of the component. You have a lot of additional information that for pure vulnerability analysis, we don't really use today. But really, you have to understand when you generate a SBOM, what type of usage you will do for your vulnerability analysis, and could make sense to understand that you will need PURL, CPE. You can review if it's already integrated and convert CPE to PURL and PURL to CPE. It's not so easy. It exists. I don't add the reference here, but it exists. A public repository, again, that makes the conversion. But the best way is to extract the information from the sources. I mean, when you are generating your software bill of material. That was just few information about how to uniquely identify your component. And this is the two words we can find inside the existing software bill of material. Let's now deep dive on Yocto. And maybe just back to the basics. Inherit, create SPDX, bit by bit, and done. Conference finished. Very easy to integrate, very easy to generate. And at the end, you will get files deployed directly into your deploy folder with a lot of different information. So SPDX format generated by Yocto is built on multiple files. You will have a main file that reference SPDX file for all the different components, all the different package recipes that is integrated into your system. I will not deep dive on how it works. There was this morning a conference done by Joshua about how it works. But what is really important to understand is that even in current latest LTS, Kirkstone and Scarthgap, you have some option to enhance or to package or to include. So all the value I've put on the right part, you can find all the detail into the documentation, but will help you to integrate additional information, to extract the sources, to make a prettier version, which is more human readable of your SPDX file generated by Yocto. That is more SPDX 2.2. This is how it works. And you can continue to use that now, but it is more like it works before the new 3.0 integration in Sci-Hub. So what's new today? SPDX 3 supports 3.0.1. It's the new default model. So if you generate SPDX without specifying anything in Sci-Hub, you will get an SPDX 3.0 format. You have a new option to extract the information you want. I was talking about the profiles or what we call also the scope. You can specify which scope you want to integrate into your software bill of material, which could make sense if you only want, for example, licensing, or if you want only to concentrate on cybersecurity topic. Everything could be configured easily. You can integrate this concept of VEX, which is the vulnerability list inside the file. that could make sense in regard of how you plan to manage your vulnerabilities. But that's always a key question about how do you plan to make this management of vulnerabilities, and what format you plan to use, and at the end which tools you need to use to make this analysis. You can definitely work on generated file by CV check, which works well, but need to be reviewed as a standard on text file, CSV file that is not always easy to manage when you are doing this maintenance. Even if it's mainly this type of long-term and security maintenance are mainly done by guys with the Linux knowledge. You also have in the team doing long-term maintenance, as we can see at our customer premises, guys with more cybersecurity knowledge, which are probably more happy to work with high-level tools that will help in overview, search, and identify what they want to identify inside this list of potential vulnerabilities. Yeah, that's SPDX 3 format. And this is, if you want to see more about the BB class, I put the reference here. Let's finish with maybe a more feedback about our approach, about how we are working at the embedded kit and what we can provide. We started developing our ecosystem of tools, including our CV scanner 3-4 years ago. And we definitely don't find in the reference SPDX format all the information needed for doing the extraction of the vulnerabilities we want to do. Today, one of our goals is to help equipment manufacturer to simplify this maintenance process. As Martha said, it's really important to find the good tools for doing that. It exists a lot of, and we really focus on extracting as accurate as possible list of vulnerabilities in our tools. And one of the main issues with all this extra vulnerability extraction tool is about the false positive, because the false positive is time you will spend to analyze something which is not applicable to your system. And at the end, the time spent for doing a maintenance could be just crazy if you have all vulnerabilities of your system not properly filtered because of the basics is just version mismatch, for example, which is really basics and really well done by all the different tools. But if your component that you have integrated into your image does not fit the applicability of the CVE information you can find inside the NVD database, for example, you will spend time to analyze that, so you will lose time. So we try to aim to integrate a maximum of information into the software bill of material, to integrate a maximum of data that will help us to filter as well as possible the list of vulnerabilities. So that's why we need to integrate into this software bill of material the package that have been patched by the meta layer, the package configuration, all the kernel configuration option. And we are able, for example, to associate software CVE with some kernel configuration to remove it if the kernel configuration is not included into your build of your image. We have our own database of association, but we also use a Ubuntu tracker that integrates this kind of additional information on top of the NVD database, which is also an interesting source of information if you are interested by this vulnerability management. So all of this information does not really fit in SPDX 2.2. That's why at the beginning of this story, we have decided to create our own SBOM format. This SBOM format and generation of software bill of material is publicly available and open source on our GitLab repository. So that's stuff that you can definitely have a look if you want to understand which kind of information you are using to identify as accurately as possible our SBOM. Now we are thinking about SPDX 3. because with SPDX 3, you have something out of the box coming with Yocto. You have a lot of metadata and additional information you can include. And all the build information can be included inside the SBOM, which makes really sense for doing our vulnerability analysis. One big issue with SPDX 3, and that's maybe just a personal issue point of view, it's the size of the generated file. A compressed SPDX 3 out of the box for a standard distro on StyHead is about 250 megabytes in a compressed format and about 2 gigabytes in a non-compressed format. That makes a lot of question about how I will manage the history of this bill of material, because when you are doing a new release, you are generating a new bill of material, you will have to archive this software bill of material, because you need traceability as soon as you are working with cybersecurity activity. A lot of audit and traceability is needed, and you may need to be able to look at how you have changed your content of your image. For example, generating changelog directly from the software bill of material is something which is really nice. So you can directly using simple script extract the difference between different SPDX or between different software bill of material in general. So helping the product team to understand the changelog and also understand what have been upgraded in terms of version of system, version of component. So SPDX 3 is a really good answer for all of these questions, all of this topic, but it's heavy to manage and the data model is quite complex. So yeah, nothing today defined for us. Really happy to discuss with everybody about this questioning we have. Last topic is about what will be the future. Do we have a day only one standard SBOM format? Today there is a lot of debate, and if we take the example of Qt that just released these new tools for doing SBOM generation, they have selected to support both of them, SPDX and CycloneDX, and they support SPDX 2.2 for the moment, and they are thinking about CycloneDX. There is always this question of standard. So for the moment today in our tools, you have defined that you can input the format you want. We have our own format that we generate with our own meta layer. That integrate all these different additional and added value we think, at least for this vulnerability generation. Then we support CycloneDX and SPDX 2.2 and 2.3 now, and we will integrate SPDX 3 in the coming months. So that's it for me today. If you want to know more, if you want to have a debate about this software bill of material topics and at the end vulnerability management, really happy to answer your question. As I said, vulnerability SBOM, and maybe as a conclusion, is really a topic for the three main topic: manage and understand what is included into your image, and could be a key topic for reducing the image, because reducing the image is a key topic for cybersecurity, because reducing and limiting the unused component really makes sense, because it will limit the number of vulnerabilities. Really makes sense for the licensing model and understand all the license components integrated, and for sure a key topic for vulnerability management. CRA coming in the UA is making a lot of questions and we have a lot of our customers that are asking about how they can manage this stuff. And yeah, if you want to contact me, don't hesitate. You can find my email address here on LinkedIn, also available. And thanks a lot for. And let me check if there is some question now.
Yeah, while you take a look at the chat, thanks a lot, Pierre. you are fitting the speaker timing bill a lot better because it's the usual 4 to 5 minutes again for your questions. So, anybody, what do we have?
What? Which format do you use for CV scan? That's today an open source and different format that we have built to answer to your needs, and you can find more detail on our GitLab / the embedded kit. That's okay.